A 0.175 molar weak acid solution has a pH of 3.25. Find Ka for the acid. Okay, so what does that mean that we know? Well, if we have the pH, we can find what? We can find the hydronium concentration. So we want to do that first. So I know that pH equals the negative log of the hydronium concentration. But I'm given the pH, so I know that 10 to the minus pH equals the hydronium concentration. So I plug in what the pH is, so I'm going to take 10 to the minus 3.25. When I do that calculation, I got 0.000562341, but I only want how many significant figures? I want 3, so I'm going to have 5.62 times 10 to the minus 4th molar, and that is my hydronium concentration. Okay, so that's step 1. Now what am I going to have to do? Well, if I know the hydronium concentration, and I need to find Ka, I've got to have an equation to do that. Oh, I got to use a reaction, right? So I'm going to have to use the Rice method. So R is my reaction. We know that it's of some acid, so we're going to call that Ha, Ha, and that's going to be in a solution of water. That's at equilibrium. Remember, the water becomes the hydronium ion. And then to the Ha, or the Ha, I'm going to lose a proton, so it becomes A minus. So what is the initial concentration? Well, I already found that, right? I found that it is 0.175. That's what they told me. So that's for the acid. So I've got 0.175. Water's a liquid, so we don't care about it, and we didn't start with anything of the others. Now, what about for the change? Well, that's what we just solved for, right? We found the hydronium concentration. So remember, it's minus on the left, so this is going to be minus 5.62 times 10 to the minus 4th. And over here, we're going to have plus 5.62 times 10 to the minus 4th. And we're going to have the same thing for this one. So then how do I find equilibrium? Well, I'm going to add straight down. So when I do that, I'm going to get this number minus that. Well, this to the negative 4th, that's pretty small, right? So this is going to be approximately 0.175. Here, I'm just going to get the same number because that's the only thing I added. Anything added to 0 is itself. And same thing with the next one. Okay, so far so good, right? So now how do you find Ka? Well, I know that Ka is equal to the concentrations of the products over the reactant concentration. And then I just need to plug in what I know. So I already know everything. So I've got 5.62 times 10 to the minus 4th times that same number, 5.62 times 10 to the minus 4th. And then the concentration of the Ha, which we said is approximately 0.175. So now I'm just going to crunch that on my calculator. And let's see, I just got 1.792 times 10 to the minus 6. Now, how many significant figures do I want? Well, there's 3 in each one of the given, so there has to be 3 in this number. So I'm going to get 1.79 times 10 to the minus 6. So that's my value for Ka.